Perfect. Let's begin. I think whoever joins can join in later. So, welcome everyone to this webinar series 101 for system design. I'm Keshav Peswani and I work as a principal engineer with Expedia Group. I've had experiences in developing very large scale systems, which includes the distributed systems as well as contributing to the open source world as well as working in the machine learning and the neural network side of the stuff. So, and when you build these kind of systems, you get to know that there are two sides of designing a system. One is the interview side of the stuff, and one is the real world side of the stuff. Because real world has a lot of its own challenges, which maybe you can't delve into in the interviews 1 hour or kind of stuff. So we in this series we'll try to cover both aspects of how do you approach a problem, how do you from the interview side of stuff or interviews perspective, but then how do you even solve it from the real world perspective, because that's very important. You can switch companies, let's say from A to B, B to C, but then as in when you grow in your career you would be given projects, and unless and until you know how you are trying to solve or how you can solve a problem, that's where you cannot grow. There'll be a plateau that would come in your career, and that's where system design helps you, or understanding system design helps you in doing that. So one thing that I've also known or understood in my career is that you don't get to work on a lot of things. Like, you can only be focused on one side of your projects, but then you have to also understand the breadth of the stuff, and that's where when you come together as people from different companies, you can share your knowledge and you can share your experiences, and that's where we can together learn as to how we can design a system in a better fashion. So before we even begin, I would like to set up some ground rules. There would be no presentations. It's all interactive. So the more you ask, the more you interact, the more you learn is the concept. It's a very simple concept. We would be pausing in between for questions, and anyone has any queries, they can post it in the chat, or they can ask the questions or raise their hands. We would be more than happy to answer that. Please do not hesitate. The reason being, see, I cannot see your faces, so just don't hesitate in asking that. Maybe the terminologies or whatever we'll talk about, please don't hesitate to even ask, or again, or let's say we can stop there till the time you don't understand. The more you ask, the much better everyone will understand. And apart from that, yeah, it's happy learning time for everyone. So the way we'll move forward with this thing is that we'll first go with the basics of system design, and we would take two type of the system design stuff. One is from the interviews perspective, and one is the real world challenge perspective. The second thing is then we'll take a problem with a very limited scale, a very simple problem, and then we'll delve into how we can solve that problem, and eventually we'll see how that, if the scale of the problem increases, how would it increase to the next level. Like whenever the scale of the problem increases, how the solution that you guys would have designed, can it fit into it, or is it something that you need to change, or what are the challenges that would come with that the solution that you had designed for the simple problem. So with that, I'll kick off the basics of system design, the first part of it, from the perspective. So let me share my screen quickly, and let me walk you through certain parts of it. So give me a minute, I'll share my screen. Perfect. Can you guys see the screen? Is it visible to everyone? Perfect. I get a thumbs up from Anisha. So perfect. So system design. So the basics. So I'll take two parts of it, as I told you. One is the interview part of it, which has four things. The first thing in the system design world is, whenever there is some problem thrown at you, any problem for system design, um, let's take an example. Let's say you want to, somebody tells you to um, do a let's say for HLD, somebody tells you that design a Netflix system, or for an LLD, somebody says a library based system, or like library system, library management system, and all those things. So the first thing that we as people we should see is always we should understand and write down the functional requirements of the system. So when I say the functional requirements, and there are some chats, okay, okay, perfect. When I say the functional requirements, what I mean is what do you expect the system to do? Like, let's say, taking the example of Netflix, of course, it needs to stream the movie. So maybe one of the functional requirements is to stream the movie. Do you want to build a recommendation, like a movie recommendation engine with this? So maybe that. So these are the functional requirements that are there. Now comes up the non-functional requirements. So in the non-functional requirements, the thing is that how much is the latency of the system? Like how fast do you want the system to respond? So this is the latency. How is the throughput of the system? So you have to come up with these numbers. Like there needs to be an expected numbers that you need to come up with. So let's say the latency you can maybe for uh, Netflix movie recommendation could be around, let's say, 1000 ms, 1000 milliseconds. So you can think of such kind of numbers, and there needs to be a reasoning behind these numbers. So and when you come up with these numbers, let's say I want to understand the traffic of Netflix. How do you figure out what's the traffic of Netflix? How much can be how many requests can come to the Netflix streaming service at a single instant at peak, is what throughput is. And you have to think of those numbers, because I mean that needs to be a realistic number. You can't just put in anything or everything in play. So you need to understand how Netflix would or can function. One way, like I can give an example. Let's say somebody asks me design Netflix, and I have to figure out what's the throughput, and it's interview. So you need to understand that you cannot spend a lot of time and effort in figuring out this thing. And maybe what I would do is, let's say, if I'm working from this part of my thing, like if I'm in India, and if I'm considering the APAC side of stuff, because if if there is day or if there is evening in the APAC, there would be morning or working hours in the US time zones. So it will compensate each other. Now, if I see India, India has a population of more than a billion people. So uh, that means I can easily say at max there would be billion folks trying to access Netflix. Now, which part of Netflix and all, there is a lot of complexities in it, and we'll delve into it this thing later in the series. But I'm just taking an example. We need to also form a lot of calculations around it, and there needs to be a proper reasoning. But these are non-functional requirements. Along with it, we always need to talk about whether your system is consistent or available. When I say consistent or available, I mean, of course, the system needs to be both, but one needs to take a precedence over the other. So when I say consistent, it means it should always give you the right answer or no answer. But in availability, it should say that it will always give an answer. Maybe the answer is correct or wrong. That is up to it. That is questionable. So in case of Netflix, we can always safely assume that our system should always be available than consistent, because it's okay. Let's say there is a title that is released in Netflix and it's available on US. It's available in US, and after 2 minutes it becomes available in India. That's completely fine. But in case the Netflix is not working, so if there is no answer, that would be a bad user experience in the world of Netflix. So for us, in the case of Netflix, it will be always availability taking precedence over consistency. Then uh, comes up the HLD part of the design, wherein you draw the high level design diagram, and maybe the interviewer would ask you the LLD part, wherein it will uh, for a particular component for or for certain things that it will that it the interviewer is actually um, curious about. So he or she will ask you that. Combined with HLD, these two things, the fifth part is the most important and the dangerous part, which is the questions. So that's where design comes into the play, and that's where your experience and your interactions come into the play. You can easily learn about the first four aspects. You can go through a lot of, there is grokking interview, there's a lot of other stuff. But the problem is they'll only walk you through one, two, three, four. The thing is the fifth one, wherein you have to answer certain questions that were asked to you based on the HLD and LLD that you drew. And that comes up with A, interacting, B, actually doing real world problems. So this is very important. That's where like I always tell people that design is all about protecting your like the design that you have made. So you need to be able to answer the or answer the questions that are asked based on the design that you presented. And there is no right or wrong answer. This is not a lead code problem or data structure problem that you say, you know what, there is a problem and this is the right answer to it, or this is the right type of a solution. Yet you need, yeah, you can solve it in a brute force manner, but DP is the right answer. In the system design world, there are like numerous solutions to the same problem, and all are right and all are wrong. It all depends how you can protect your design. So with this thing, we end up with the interview side of stuff. Anyone has any questions with the interview side of stuff? Anything that is not clear? Any terminologies? Anything you can raise up or ask in the chat or anything? Perfect. I get a thumbs up from Maria. Anyone else has any questions? We can move on to the real world side of stuff and why do we need it? So, oh, there is a chat. Yeah. So, there's a question: is partition tolerance included? So, sorry, generally, the reason I didn't include partition tolerance is most of the systems that you design is always partition tolerant. When I say partition tolerant, it means that in case there is a network failure, or in case there is a let's say you deployed a service, you'll never deploy a single instance of a service in any environment. You'll always have multiple services, like multiple instances of the same service running. So if in case one or two services go down because of a network failure or because of some issues, still your system is still functioning. So partition tolerance will generally be there. So, and this is more of like system design kind of a stuff. This partition tolerance is generally a part of the CAP theorem. So CAP has this kind of thing like consistency, availability, and partition tolerance. But over here, this is generally taken always into the consideration. Does that answer the question? Okay, perfect. Cool. So This is the interview side of stuff, and the reason that is this is limited to this particular part is because you only have 45 minutes. So 45 minutes, maybe maximum an hour, and that's where you have to uh, basically try to impress the interviewer, and that's much you can do. But in the real world, wherein you have to solve challenges, there are a lot of other things that you have to take into considerations, and a lot of there are a lot of other things that you have to take into considerations, and there are a lot of certain um, how do I say it? There are a lot of uh, like I would say, I'll not say them hacks, but I would say there are certain uh, things that we have taken or I've carved out in my from my real world examples, real life examples that I'll talk about right now. Uh, as to like if you follow these patterns, it'll be easier to navigate in the real world. That's what I can say. I would not say hacks because hacks is not the right word in this manner. But in the real world, we have the most important thing. See, this real world is not to impress anyone, but to run a business. So always understand that there is a business angle in play. And to business, technology is an enabler. And when this is an enabler, the first thing that any business for any project that gets spin up or it's being worked upon, the first thing that comes up in mind for the business is the cost. There are three types of cost in play. One is always the development cost. One is the deployment cost or the running cost of the server, and one is the maintenance cost. So you as architects, as developers, always need to consider these three costs in play for actually trying to design a system. The other thing that is very important is when you're given a real world problem or in the real world, even in the interview time, you cannot solve everything. Like if I give you a problem to form a Netflix has been formed from over the years. So you cannot form everything on day one. Like so, same in the real world, the business problems or the business will extend itself, expand itself. The problems will change. Anything and everything can happen. So your system should be extensible because most of the systems that you or most of the problems that you get in the real world would be very vague, very very vague. And in unless until you have extensibility in play, you cannot you cannot go back and say, you know what, I today I'm building version 1 of the system, tomorrow I want to build version 2 of the system. This is simply not acceptable in the business world. They would want you to use v1 and extend it to somewhere v1 dash to incorporate new changes. So extensibility is very important whenever you are designing the system. The third thing is there is something called ideal world, or as I say, the real world of stuff, and there's something called the real world. So the ideal world would be the correct or the most apt design that comes up into the play. But the real world is the design that actually comes to life. What I mean by this is maybe on day one or on day zero, before you start the implementation, you would have designed the system as the ideal one. But when it comes to the development, you improvise based on maybe delivery times, time to market, and you come up to the real world stuff. So your system from real world goes to the real world. So there would be improvisations that you would do in the real from the real world to the real world. Then the thing is, once you design your system, so even the real world system or the ideal world system, and you have presented it out and you have a lot of things, you have passed through the design reviews and everything. One thing that you should always keep in mind is that, let's say you have three, uh, let me take an example. Let's say I'm the, like, I have to build something similar to what Netflix has, and Netflix has three major things. I'm taking an example just. I know it has a lot of other things, but let's say it has a recommendation engine, it has streaming service, and what else? Let's say it has fraud service. Now, as the architect of the Netflix or the owner of as an architect first, I have found that okay, I need to build these three things. Now, as the owner of the Netflix, I have only limited resources with me, or limited folks working with me. What was the first thing that you guys feel I should prioritize to get the things out, like to get my business running? The constraint over here is that you know what, I have very limited set of resources. So what is the first thing that you guys feel? And you can post answers in the chat, or you can, yeah, talk about, yeah, there are answers coming in the chat. Let me open it up. Streaming. Perfect. Everyone is talking about streaming. Anyone feels there is some other service that could come up? No, because unless streaming comes into the play, the business cannot run. That's the reason. If you see, I'll take this case study of Netflix only. um, they have very good user interface, UI or UX, I can say. They have good streaming service, but the new system that Netflix had, the fraud one, which is the IP lookup, like you can't run more than one TVs from a single IP, like more than one TVs from different IPs. This thing came very late, because when Netflix realized that there is a password sharing happening and people are using that, that's where they added this feature. But the first set of the order was to always get the revenue. Unless you don't have revenue, what will you build this feature for? So that is where we say that you need to have a minimum viable product, or MVA, carved out. So as architects, you should know what is the minimum viable product in this and how do you carve it out. That's very, very important, because this will help you A, in time to market with the set of resources, and B, improvise along the dev cycle. So this is very, very important with this thing. So these are certain things that we wanted with the real world stuff that you need to keep in mind while actually designing these systems. So and one more thing, always remember that whatever problems that you get in the real world, in the interviews, it's very standard set of problems, but in the real world, the problem's gonna be very, very vague, very vague. And as in when you grow in your career, that vagueness keeps on increasing. So system design is all about, like, the 50% of the challenge is solved when you understand that the problem is vague and you've figured out the first set of requirements for that particular problem. You won't get all the set of problem requirements from someone, so you have to understand that fact. So yeah, probably this is what I generally keep in mind with my real world problems that I get to work on. Um, uh, is it fine? Anyone has any questions, anything that you want to discuss before we move on? Nothing? Perfect. Okay. So if that is the case, let us move on to the next set of thing, which is the problem. When I say the problem, I am saying the simple problem. So let me paste this problem in the um, chat. Just give me a minute, and I'll also paste it eventually over there. But yeah, just give me a minute to paste it in the chat. Can you guys see the problem? Perfect. And I'm also pasting the same problem in the. So yeah, the problem is you have. Sorry, there is a railway station with M platforms and trains are arriving. Each train has an arrival time and a departure time. Write a system that makes the train arrive in the order of their arrival in any platform and depart at their departure time. So the way we would go forward with this problem is just setting up certain things around it before we even approach the solution to it. We'll we'll first, or I'll first allow you guys to go back to just see how you would like to approach this problem, and we'll discuss the solutions that you guys come up with. As I told you, design is all about protecting stuff. So you have like I think more than 20 folks in this call, and they would question you. So it's just not me who's going to question. It's the people in this call, and that's the beauty of this thing. And eventually, at the end, I'll tell you how I would like to solve it and how I would like to approach it. So do you guys want to take some, like maybe a minute or 2 minutes to try to solve this, just come up with the stuff? Or how would you even approach it? I'm not even saying the solution part of it. How would you even approach it given the stuff that I showed you in the previous two things, like an interview and the real world? How would you like to approach this problem first? Guys, you can speak. I think we can unmute everyone and they can speak if they want. Let's try to keep it interactive. In are you guys allowed to speak? Or like do you need to unmute you guys?
Yeah, I have unmuted everyone, so you guys can speak.
Okay. So there's one last request that please be more please speak up and please have be more interactive. That's where you learn a lot.
So, hi Keshav, am I audible? So, I think I will first focus on the synchronization thing because the main concern is how I can synchronize this. Because whenever a train comes, then first thing we have to do, I guess, we have to lock somehow.
I'll stop you there and then. Sorry to
Yeah,
interrupt.
sure.
The reason is that when we discussed the problems or the thing, even from the interview perspective, um, we
Okay.
have not come up with the functional requirements at all. This is a vague
Yeah.
problem. we need to first come up with this functional requirement. There are a lot of things that are missing. So I would really want people to follow this thing and first come up with the functional requirements, the non-functional, and then we'll discuss how do you want to even approach the topic. So that is very important.
Absolutely.
Maybe guys take a minute or two just to see what are the functional requirements that you guys would want to come up with and the non-functional requirements. Does this sound good? By the way, is everyone comfortable with the pace that we are going with? Do you guys want me to slow down, or do you to go it much faster, or is this fine with you guys? So yeah, who wants to take up the thing? I think the first one was written by Kartika. So Kartika, why don't you come up with the functional requirements? Is Kartika on the call? Okay, she's unable to unmute. Maybe
Now I'm able to.
okay, perfect.
Am I audible?
Yeah,
So, from layman's perspective, if you asked, right, if a train arrive, I will think that whether the platform is available or not.
yes.
So, whether that comes under a functional requirement or a non-functional requirement, that is my doubt.
So platform availability is always a functional requirement because that's what you have to do. So I think first thing that I would come up with is the train should not have accidents. Like it should not go like there should not be any accidents. So that would be the first core bare minimum functional requirement that I would come up with because that is something you need to think of from the layman's perspective. And this is something like everyone has traveled from the railway systems or any railway thing. So I think everyone knows that there should not be any accidents. So that should be the first core bare minimum functional requirements.
Okay. Next, what I said that
Yeah.
if there is something a waiting, right, already if the existing train is their departure time is not at mid, then there should be some waiting lanes also to accommodate the arrival time of the upcoming trains.
To accommodate the arrival times of the waiting.
Upcoming.
So you are
Okay,
saying
waiting time. Waiting platforms or something.
the platforms,
Mainly this.
the platforms are only so it says like you if you see we kind of already said that there are only M platforms. You cannot
Okay.
extend them beyond. Like, just think of it like from that perspective that there is a platform and
What if there is a M+1 train? Where
yeah,
should the train will go?
that's what this problem is big. You have to come up with the solutions, functional requirements. So that's the thing. That's the beauty of it. So that's where you have to ask the waiting of trains. Somebody has
Okay.
raised an hand, Pradeep. I think people can't unmute Anchal and Divyansh. Can you guys unmute?
Yeah, am I audible? It's Pradeep here.
Yeah, Pradeep, yeah, go ahead.
Yeah, I had a question. When you're defining the functional requirements, would you be going a bit deeper into it, or it's supposed to be high level, completely high?
That depends on how much deep you can go in the functional requirements world. I'm taking
I mean, given an interview perspective where we only have 45 minutes to, I mean, I believe once you do give the functional requirements, you'll have to justify it too. And then you are defining the flow of the interview and how that would go on. So given that perspective, would it be better to, for example, here you have mentioned no accidents, waiting of trains, or maybe go a bit higher and say that the whole thing comes under a scheduling service, which will manage all of that and then look at the other parts?
so scheduling service is a solution to what you are trying to say, but as a requirement, it's from the layman's perspective. So,
Okay.
so you need to go and like it should be like a layman can understand these requirements and not from the solution perspective that I'll have a scheduling service. That is this answer to what these require things would want to do. Like you,
Okay.
so that is more of your solution. But
Can
right
I
now,
say some of the layman's situations if I just think about not as an technical person, just as a simple.
oh yeah,
So
sure.
what I would like is that, as you mentioned, that there should be no accidents. So obviously, the first thing I need to know that every train needs to have the platform and the arrival time, and the no train should have the same arrival time or the same platform. And if the two trains have the same platform, at least there should the departure time, the arrival time of the first train should be after the departure time of the first train. So that will at least make sure that whatever trains are coming in whatever platform, at least they are not colliding with each other.
So there
That's
are
the
two
first
things.
thing.
Um, right now, this problem says that you can arrive in any platform. So it's not like a train is tied to a platform. You can arrive at any platform. That was the problem statement. So that means you need to ensure that, yeah, there should be no accidents. Trains need to wait because they're so take in a scenario that there is a train and it may get delayed. It may have its own arrival time, or it may come even before its own arrival time. So that's a real world scenario. Do you want to incorporate that, or do you want things to be incorporated in that manner? That is important. But since the question said that it can arrive in any platform, you should not add that complexity, is what I would say on day zero for the functional requirements, because that will anything that is given is a hint that you don't want to add that complexity. I'm just trying to be playing a devil's advocate over here for you, just to ensure that if there is a hint, don't let it go waste. As an interviewer, if I was your interviewer, I would have let go and said that, you know what, yeah, please go ahead and do it. That would make the problem more complex. So uh, we'll just make use of whatever it is and given in the problem statement. So, but you said one good thing, which is that you need to have like the arrival times and the departure times consideration for a platform. That's one thing. What else?
So I think there should be like a signal or a system which signals all the trains, like whether to stop or go ahead to end platform based on number of platforms. So basically, our requirement is that trains are just arriving. Like that's like one basic requirement, but we don't want them to collide. So we have this signaling system where it says, okay, stop for certain number of times. So we want that system to direct them towards different platforms.
Perfect. So what I can say is new notification to trains.
Notifications to trains. Yeah, I think that sounds good.
Okay. And okay, there's some problem going on with the mute, and Harsh, I think you muted
Yeah.
everyone.
Yeah, so I have given the author, like people can unmute themselves. Can you try once more, Divyansh?
I think it's working now. Yeah.
Yeah,
Yeah.
it's working for me as well.
Yep.
Perfect.
Thanks.
So system to find the available platform, that's the right requirement, Ekansh. I was looking for that because that's a basic requirement. So system to find the available platform. But this is
What
an
about
incomplete requirement. So what is missing?
the system to redirect the particular trains to those particular platforms?
Sorry?
A system to redirect the trains to the particular platforms. You would have a single track or two tracks, but you'd have multiple platforms.
Yeah.
How would you then?
Yeah, you have to redirect the trains. So that's what he's saying, that at least what I understood is that you have to redirect or find the train, find the available platform for that particular train. But there is a missing requirement in this. It's still not complete.
I think Keshav, system should find the available platform like which will become available in the minimum time, because it is possible like all the M platforms are acquired at a time. So
Yeah,
we need to find, system should find the platform which will be available in a minimum time.
that's right. But what I'm saying is, let's say there are, of course, minimum time is that comes under part of non-functional. So we come to that particular thing. But what I'm trying to say is, the order. Let's say there are two trains that came at the same time now, and all the platforms are busy. And one train was on time and one train was delayed by an hour, and hence both of the trains came at the same time. Now, do you think which train should be allotted the platform, whichever the platform gets um, like freed, which train should you give the platform to?
So there should be a priority mechanism or something that if
Exactly.
a collision or some, if there is a, so some service which can make decision on this thing.
What else? Is there something that I missed in the chat somewhere? Or
Maybe there can be some optimization service. So like if some platform is more accessible, and like if there are two platform empty, so there could be some optimizing or something based on the platform, that maybe platform one is more easily accessible. So there should be a service which can suggest that.
so you're saying if there are multiple platforms available, you need to have a priority between the platforms as well.
Yeah. So
Okay.
like that could be an over, like not a immediate requirement, but later good to have kind of a thing.
So do you want to keep it or do you want to keep it under good to haves?
Not a essential requirement right now, I think.
But you need to take a call. So guys, do you want to keep it under this requirement or do you want to keep it as a good to have and we'll worry about it later? Or okay, let's do one thing. Let's keep it as a um, good to have thing so that we'll see how we can extend the solution to incorporate this requirement. Though this would have come afterwards, but let's say we already know this will come sometime later on. What else? Is this fine? I think Divyansh.
Yeah.
Okay. What else?
Maybe
Announcements.
yeah,
Sorry,
announce.
good.
Maybe when to announce for a train,
This
like
is a railway management. You have to manage the platform and the train. It's not related to any customer stuff.
mm,
We didn't give you anything from that perspective.
Are we considering any system like when a train departs, then it should point out to that system like I have free this platform and you can consider it as available.
Yep. So you notification back to the system from trains. Should I say that
Yeah.
I'm perfect? What else? Is there anything missing? What about the trains coming from both of the directions? Platform has trains and it comes from both of the directions.
Normally, you have the platform dedicated to each direction.
That's
So,
not
are
good.
we considering Normally you have the platform dedicated to the direction that, this is for the incoming and this is for the outgoing.
Okay, is it? I didn't know. Okay.
Mhm.
I mean, that's not the case generally. Like it can be both direction depending on the situation.
Okay.
I think this can be handled using the
By the
priority that
timing
we
of
have
the,
already
the
decided.
priority and the timings, that we know that the two trains are not going to, timings are not going to clash.
Yep. So when you add these things, it gives you brownie points because your solution still remains the same, but then you've added one more functional requirements to be compensated with it. Just wanted to add certain things from the interview perspective as well. That's the thing. Cool.
So isn't no accidents as in like, doesn't it cover the direction as well? Or that
Yeah.
has to be explicitly mentioned?
The accidents, the arrival and departure times, and the priority mechanism. So 1, 3, and 6 would actually compensate for 9. So your solution may not change, but adding a functional requirement always. Now, coming to the non-functional requirements. So what do you think?
System should be like very optimal, should not be take much time to like tell us that which platform is free.
So what do you expect the latency for the system to be, or how much time
Yeah.
the system should take to allow a train to an empty platform?
Yeah.
What was the optimal number you guys are thinking of? Optimal number is not the right thing. For me, it can be 1 second. For you, it can be 5 minutes or 10 minutes. So what is the optimal number according to you?
We need to consider the time given to the passengers to reach that platform as well, right?
Again, neither are functional requirements nor the problem statement talked about the passengers. So if you want to incorporate that, then we have to add a point in the functional requirements, but that will complicate the solution thing. So do you want to do that, or do you want to keep the system till whatever it is what you have decided in the functional requirements?
I think it's better to keep it to the train and platform for now.
Okay. Then what is the latency? What do you expect? What would be the
Like there should be a fixed number that should be like common for all the trains. So it should be before arrive, like when the train is arriving, it could be a fixed number before that much minutes before the train. Like it has to be decided, like what platform, like what are we exactly what latency exactly means over here.
So let's say there is an empty platform and a train has come. So how much time would the system take to actually allot that train to that empty platform? Is what is the question over here? Like,
I mean, I'd say 3 seconds, not more than that.
sorry.
Less than a second, maybe.
Okay, who said that? 3 seconds is by Anusha. I'll write it because we'll ask them to solve it in that particular manner. So Anusha said 3 seconds. What else? Somebody said less than a second. Who said that?
Yeah, it's me, Anshul. Yeah.
Okay, Anchal said.
It's not a concrete number, but something, yeah. Just assigning a train to the platform should be less than a.
Yeah, let's try to back it up. So you said 1 second, so I'll rely on you to complete it in 1 second. So as I told you, system design is all about protecting yourself. So you came up with that thing, you need to protect now. So what else? What else do you guys think? Like,
Yeah, should be consistent. The system should be consistent. I mean, it's not good that, I mean, it can be unavailable, but should be consistent. If train is already allotted to a particular platform, we should know that I mean, the train is there at that point. So it's not, I mean,
It should not give the wrong information, otherwise
yeah,
students can
basically.
flight.
Yes. Does everyone
Yeah.
agree with consistency? Taking pride over
Yeah, I think consistency needs to have a priority over availability because it needs to have a correct data.
yeah, it's the accidents, lives of people in play
Yeah.
is always important in this manner.
But
What
what happens in case of no answer? When it is consistent, it can be no answer also, no? So if there is no answer, then what does happen? Then
Then the train
what
can wait.
then the train can wait. Yes, Anshul is right.
Mhm.
What else? What is missing? What is the throughput do you expect from this system? How much? How many trains do you expect to come for this particular system in a second or in a minute, whatever? Granular.
Trains do not come in minutes, isn't it?
Like how many trains can come in a minute for a particular platform in which has for a particular railway station which has M platforms, and M can
And
be a number.
M trains can come, I
and
guess.
number of trains.
What else?
M in N minutes.
Trains are
M
M
in
platform.
N minutes.
I mean, should be M by 5. Usually trains stop at least for 5 minutes. So
Yeah, it should be at least 5 to 10 minutes for
There are
a
stations where
train to come.
2 minutes as well. I've never told that there is a station. This is like a very big station or a small. You design a system just with M platforms. So what do you expect? How many trains in a minute?
I will not expect a train in every minute, even if it's a small one.
So maybe we just for the namesake purposes we can say M trains
Yeah.
at peak.
Yeah.
But does everyone first of all agree with it?
No, but then
Yeah,
what
it
is the
can't be
point of
more
the
than
queuing?
M.
What is the point of queuing system then? Every time a platform will be available, we are assuming this,
No, we
right?
don't have a platform available every time.
So if there are M trains and M platforms only, then
I'm saying M trains at peak per minute.
okay, they can stop. Okay. Mhm.
Is this right? Somebody said 20 M or it's 2 M, 2.0 M. Suraj, 20 M. So Suraj has to protect now 20 M. So I'll write his name.
It's not 20 m. I think it would be around 12 m if I consider 5 minutes of waiting period, and every train, like every in and if a train comes at each platform at one at once, and it is redirected to a single platform, so it multiplies with m times, so 12 m. Considering 5 minutes of waiting period, like if the train comes and then departs, 5 minute gap is there.
No, that's okay. But what is your throughput or what do you expect at peak to come? You're considering a very normal scenario wherein you say this thing. But consider this situation. There is a fog and all trains are delayed and they're coming at the same time now. I think there was a same situation in the airport world this time. There was a fog and all the flights were there. There were no hangar places. The runways were filled. So what was the peak traffic at
So
that
are we talking about the waiting? Because at one time, only let's assume it's a one platform, only one train can
incoming
come,
trains?
whether it's a peak or not.
So this is an incoming train.
So basically, I would put it in a way at a given point of time, how many trains can request for a platform?
Yes. From
So
your
M is max because that's the number of platforms we have.
no, this is M platforms, but I would generally keep it at least like what he said 12 M at max to solve my if there is a lot of traffic coming in. Minimum it should be 5 M. The reason is that we say that if there are M trains coming up, average stoppage time for a train is there are train stations that are 2 minutes, and they can come late, but then they depart early. Is like there are times when a train will stop only for a minute or something. So and due to such weather conditions, it can be that the traffic on that particular station increases and maximum goes up by 5-fold. So on a happy scenario, it would be m trains per minute, but in a worst case scenario is the peak scenario that comes up as 5 or 12m. That's okay for you to justify that part. So either it can be 5m or a 12m.
Is it 5 minutes, you mean?
Per minute.
Okay.
Uh,
Got it.
5M means like if a M
5
platform
into is
there.
yeah, m is the platform number. A number of platforms, sorry. Okay, so with this, we have the next very important part, which is the design part of it. Sorry.
So I mean, I couldn't quite understand. 5M is like 5 times
Yeah,
M
5
or
times into m
5 minutes? Okay. Sorry.
per minute.
Five trains per platform. Sorry, just clarifying that.
Yeah, thank you.
Okay. Design. So what do you expect in the design? So what we should do is first we'll understand does this designing or the solutioning, now is the solutioning part of it. Is it an HLD problem or is it an LMD problem? First, let's try to figure out collectively whether you want to go for an HLD problem or an LLD problem in this. First of all, do you guys understand the difference between a high-level design and design problem? Guys, speak up. Now you're all on mute, so you can speak up and talk about it and you'll learn. Is it an HLD problem or is it an LLD problem? Even take a stab at it. That's okay.
Like it is like both only. Some algorithm has to be defined for LLD also, like how you will do the scheduling, how you will do the priority thing.
Okay.
But high level design also we need to store the data also somewhere, and high level designing is also required. Like both type of things are required in my opinion.
So you said high level. This is algo needed and for scheduling and all those things. So I'll say that's an algo only.
Correct.
By the way, we are not looking for the most efficient algo. We are just looking for the correctness in the algo right now. Can be brute force also. And the HLD, you said you need to store data. That's the reason you need to have an HLD problem as well. Does everyone agree to it?
I would say we start off with HLD and then move into LLD with specific algorithms.
Yeah, na? Okay, yeah. My bad, I wrote it in a different manner. But of course, we'll start with HLD. But what I'm saying is, does everyone agree that we need HLD because we need to store data and LLD because there is an algo?
Not only because to store data,
Hmm?
but also like how will the services interact with each other, and like all the high level aspects we do not know. How are we relating all the things?
Okay. So, okay, let's start with HLD. Does everyone agree to it? To
Yes.
account for scalability. Somebody said to account for scalability. I didn't understand what does that mean. It just came in the chat. Naresh, can you
I think he's talking about the scalable system, but I think that's something we will be thinking about once we how to design the service. I think first, huh? Scalability will come later. That's what my think is.
Yeah. So this thing, do you guys think this is a scalable system? Okay, let's talk about from that angle. Is this system a scalable system or is it's a normal like very limited traffic system?
I don't
It's
think
not
it's
scalable.
scalable because you cannot increase the platforms, right? If there are M platforms, there are M platforms.
Exactly. So from that perspective, the system is not scalable, or the scale will not increase like in exponential manner. Maybe, yeah, there would be more trains that would be added, but that's it. And how many platforms do you say? Even if you talk about, let's say, any major city platform, will add one or two platforms maybe in couple of years. So that's not the scale that expands out. So the scale will come up eventually once we design this problem, and then we see when we see there is a problem with the design, then maybe we'll add the scale to it. But then right now, from till this perspective, we don't have any scale. I don't feel so with the platform, with this thing, with this problem. But in the design part, let's take 5 minutes. If everyone agrees that there is an HLD thing to be done, let's take 5 minutes for the HLD. And if people say that there is no HLD to be done, they can go for the LLD directly. So they can take those 5 minutes for the LLD part. And you can write like whatever you guys are taking the approach, and then we'll try to streamline everyone's answers into part. So please write whatever you guys want to do, like what approaches you guys want to take, whether you feel it's an HLD problem, then go for an HLD plus LLD, or if it's just an LLD problem, just then go for an LLD. Anyone is facing, okay, there's a question regarding throughput. I'm not sure if it should be related to M, as there could be many trains requesting for a platform. They wouldn't be able to get it based on the number of platform, but TPM should be related to that. So Vanshaj has come up with this thing. So whoever was saying 12M and like a multiple of M, so how would you defend your thing now? Maybe I think Anchal, Anusha and Divyansh, you guys presented with the M, like a multiple of M. So Vanshaj is asking a question to you guys.
So like this is a vague problem. So we are just considering a number that is a little bit practical. So we cannot consider just like if there are a billion of trains, so all will come at the same time. Or if there are million of trains, all will come at the same time to that platform. So we do not have to overscale a system like when it will practically not be that much. So yeah, in an ideal world scenario, we can consider infinity trains will come to that system, but like actually what because we have to take a number, so we cannot randomly take a number. That is why, because we know a platform has so there are M platforms in the station, that is why we need to relate the train with that thing. So it is just a vague thing only, but yeah, instead of coming up with a random number, because there can be as many, that is correct, but practically there won't. So yeah.
Vanshaj, does that answer your query, or do you want to counter it out?
Yeah, I'm not sure. So, I mean, it shouldn't be dependent on. So, I mean, yeah, because we already have one variable. So, but yeah,
Let's say if it's not dependent on that, then how would you figure what like the through like how many trains can request for that particular system from that particular system or platform at a given instant, like at a given minute, in a given minute, or in a second, or whatever?
yeah, that's why I'm not sure what's the metric we can use, but
So
M M is not a correct way. I mean, at least in the real world. You see
so
that?
okay, so you have to come up with a practical number, and I think 5M or like a multiple of M actually helps you solve that thing, because a any uh, station that is built, or any station that is built in India or anywhere, is built in accordance to the number of trains that are stopping in that and at a given instant. So it's not like of course there can be thousands of trains stopping at the station across the day, but at a given instant, there would be n or m number of trains that will be stopping in that station. So in order to achieve that, that's where they keep on extending the platforms to increase the load or improve the load on that particular station. But then at least I feel that's always a number related to m. Cannot be 5m, can be 10m as well. That's perfectly fine. But it can be related to m as what I feel. The trains passing through that particular station and not stopping is a different thing altogether. That's irrelevant to m. That can be many trains. And then that number can be, there is a way to figure those numbers out depending on the platform and all. But then for this particular problem, I think m having a multiple of m, which can be anything, actually would give you a practical approach to the problem.
Because I think if a station also have more platforms, then obviously it has more platforms because more trains will stop in the station on that station. So it is related somewhere to M only. So if there is a big station, it will have more platform because more trains will stop there. So it can be related.
But if you
Yeah,
know
I
a
think it's
number,
more about
we can take that number as well into consideration.
I think what Keshav, you mentioned earlier that this 5M, we are talking about how many trains can request for the platform.
Yes, at a given minute, in a given minute.
At a given minute, yeah. And that's why we came up with the 5M that, maybe 5 trains can request at the time of like fogs.
Yeah.
Fog, that's what you said, yeah.
and why M is related to it is because like if the trains are arriving at a particular station, there is always that awareness that there are M number of platforms. So M has to be related in some way, is what I feel.
One more thing, like we cannot have a very huge number as well, like 100m or 200m, because if you increase that k factor, then that basically means you are basically increasing the waiting time for a particular train. And so we have to also consider, like we discussed, like the average waiting time around 5 minutes or 6 minutes. So yeah, we cannot take a big factor of m as well.
So yeah. So about the HLD part, did anyone got the HLD part or want to share about it? So Devyansh, you had that HLD.
So it so first, for example, we get a request from the train that I'm arriving, I want a platform now.
Mhm.
So now there needs to be some kind of a service, for example, a platform allotment service, and that will talk to other services like the priority service, scheduling service. So something like that.
Platform allotment service. Then it talks to
Maybe it talks to the priority, to the
priority
schedule.
service.
So
And the other one, what you
like,
say?
so priority service can have some a store or a database kind of a thing where it can clearly like pick the first available platform. So like there are orders of platform, that platform one is in priority right now. So no, not the priority, means that would be a scheduling service kind of a thing, which has a database that just gives the number, like which platform is the best to for that train to come right now.
But you have very limited set of trains. You need a database to be kept.
Correct.
You have very limited number of trains, and M in the real world can be like yeah, you
Yeah,
can.
it is a finite number.
It's a finite number in the real world.
Correct.
You
We
don't.
can simply store it. We do not need a database.
Okay, one learning that I'll give you is never think of it as a 10 to power 4 or 10 to power 7 kind of a problem. This is a real world problem. The real world problem demands the correct answer, but not an over engineered answer. So this is something like I think that's a shift in the mindset, that you always think of a problem from the real world angle, not a LC problem angle.
Correct. We can store the data like in the service only. There is no need actually.
So
But we need some kind of persistent storage, right? If the service goes down, then the data is lost if we store it in service.
So you guys need a database, or you can store it in a service and maybe read it from there. On day one, I'm just saying, do you need to incorporate a complexity of a database on day one when the data is very limited? Questions, thoughts, anything, guys? Be interactive. We'll be interactive. We can learn
And
together.
also, like, we want consistency as well, so that multiple instances of a service has an access to the data, like, so that they can return the correct answer always.
Okay. So you want to keep it in the parity service, or you want to have a database then?
I mean, database would be an overkill. Like, it will be, and like very less data we will be storing in that. So what I think, we can go to file-based storage as well,
Right.
but I don't know.
Okay. But I wanted to understand, you wanted a platform allotment service, and what else services did you need, Divyansh? You were talking
So
about.
I think that so some things has to be like, so for example the request from train, that will always come from the platform allotment. So whatever other services are there, for example if we have a scheduling and a priority service, so for example they will give events which will be read by the platform allotment service only, something like that. Platform allotment cannot directly like call the scheduling at that time or something has to be worked out in the background and give the data to platform allotment, that whenever the train requests, so it gives the correct platform.
But with this scale, do you think we need separate services, or can we have something called platform service
Where all the logic is present, that also.
and then put these things inside? Like, why do you want to incorporate such things on day one?
It
Again,
will
the
only
scale.
be complex. Yeah, it will only be complex because the scale is not much. We can simply have just one service and the algorithm running inside that. And simply it can also give.
And a database with the, I guess, just the trains and the times.
Actually, now I'm questioning HLD part itself. That is HLD required only. Because there's nothing, just one service and one algorithm will only be there.
Cool. I actually could have stopped there and then, but I wanted you guys to come up with this and then question whether you wanted to have an HLD or not. But always, if it's an interview, see, if it's in a real world, you always get a lot of time to design these things. But then if it's an interview, you have to think at that time that if you steer, nobody will stop you. And the thing is, you'll waste a lot of time in actually doing something which was not required for this thing. So, because you are on a time crunch, you have 45 minutes or an hour or something, and then you've wasted at least 10 to 15 minutes in doing this thing and coming up with this entire stuff. So, does everyone agree that it's with this scale, you need only one service and you can incorporate the entire logic in it? With a database or a file-based system, that's a thing, but you only need one service.
Yeah, I mean, now after the discussion, I think we'll just need one service.
Others, Anchal, Vanshaj, and there are so many others on the call. I only see
Yeah,
four.
I think we can proceed with assuming that one service should be fine. For now, it's solving our purpose. So
Perfect. So if the HLD is solved and we only need, actually it's not solved, actually it's not needed for this problem. So let's come to the LLD part of it. Did someone think of LLD while everyone else was thinking for HLD? Like anyone who came up with the LLD thing, and they thought that, you know what, HLD is not needed and we'll focus on LLD? Or anyone even thought of that, like in that direction? I know people tend to follow, or there's a collusion that happens because everyone was saying HLD and then everyone jumps into that. But did anyone think of that, you know what, LLD, we should think of LLD. It's okay, you didn't speak out, or that's okay. But then, did anyone in this call think about that this is an LLD problem and not an HLD problem? Okay, no one then. Okay, no issues. Okay, let's take time and let's try to solve LLD. Okay, let's bring down this thing. Let's try to solve how would you allocate. So there are trains coming, and how would you allocate the train to a platform, and how would you ensure that your functional requirements are met? You want, I can take a snapshot and paste those snapshots of these requirements in the chat, or if everyone is aware of it, then that's fine also. Do you guys need this thing in the chat, or you guys are fine with this, the functional requirements? Okay, we'll take maybe a minute or two, and then we'll start with the LLD part. Just think about the LLD part. We'll Once we discuss, I'll just also talk about how I would have approached to this particular problem and how I would have solved it. Okay, are you ready? Has anyone thought of the solution to this problem? Vanshaj, others? Yeah.
Yeah, hi Keshav. I don't know I'm like fully correct or what. I just understood few things. Like we
Perfectly.
need a queue, like we need some kind of a queue whenever a train come, then it should like there should be a queue in which we can keep that train like this is came first, and like first on we can manage some first come first serve basis kind of thing.
So
And
you want to keep a FIFO queue?
yeah.
But
Am I
do we need to consider direction? FIFO, would it work with the direction?
The priority will also be an issue in this.
Yes, the priority
Yeah.
is what we had decided, that we need to give priorities to some trains. How would
Yeah.
you ensure it in the FIFO queue?
Basically, we should have multiple types of scheduling patterns. I mean, kind of a strategy kind of thing. And multiple types of strategies. We can schedule in multiple ways.
So
There's
if you
guide.
have multiple types of scheduling patterns, how would you ensure which thing falls into what? And tomorrow, if there is one more thing coming in, don't you think that you keep on adding more and more stuff into it? Can you try to make it a little bit more generic? How would you guys even approach this problem? Like, let's say um, you understand this is an LLD now, and you need to form the LLD part of it as a uh, like the like as an architect for this particular problem. How would you even approach, like, and try to explain it to me, like, you know what, ho- this is how I will do it, rather than directly jumping onto the solution? Because
Can I take a stab at it?
yeah, sure.
Yeah, so what I was thinking was when the train starts arriving, you get a request. Basically, the system needs to get a request or a notification saying that I have arrived, and then that gets prioritized. Let's say train number one has arrived already and all the platforms are empty, then you will allot one of the platforms. Similarly, like there are five different trains arriving, one
One,
after the other.
let me write it down. So you say request a platform by a train,
Yeah,
and you check for empty platform.
correct.
Yes, you allot. What
Yes.
happens for no?
Wait or stop.
How would you do that?
So notify the train back saying that you stop. Basically, we expect that there is a signal for train, like a signal system that is available. If none of the platforms are available, then you ask the train to wait.
Okay. This is
Notify
what
to
you
stop.
said.
Yeah.
Yeah, okay. Then what?
So now let's consider at least I would consider the worst case where we have like we came up with the throughput saying 5M. For example, we have 10 platforms, then we have 50 trains with that throughput that we came up with. And all of them have a waiting time, but we prioritize based on the arrival timestamp. Like let's say train 1 arrived at a particular 101 time, then that gets prioritized over something which came like 1 millisecond
But
later.
where are you keeping it now? I'm not getting it. You started off right that you request a platform as a train. So,
yeah.
but then how would you?
What is a train?
Storing all.
I think first we need to define like what is a train exactly, what should it have?
Exactly.
Like train should have a name, arrival time, departure time, the priority and the delay. So these aspects should be associated with the train to do
Exactly.
something.
I think the two main components are train and platform.
Yes.
We need to
Because
define.
that's what we are
I was
communicating
looking
between.
at. So there is a train number. Like I'll just be very short and crisp. We can always expand integer and all those things, but I'll be very short and crisp over here. Train number is what you said. There is departure time
And arrival time.
There's
Priority.
arrival time. Maybe there is
No,
some priority.
There
Actually,
should be a decent time also
actually,
stated.
what we should do is we should not keep a priority with the train. That's an internal.
No, yeah, yes. Because for train, it's just its arrival time, departure time, and its number. That's it. Train is just interested in that.
We should keep its status, whether it's a passenger train or it's a super fast train or something of that sort. Like that gives you a like a like a property for the priority to be set. Like let's say if there is a passenger train versus a goods train, you would always give a priority to the passenger train. Like so that this will always show that you're thinking for extensibility in future.
So isn't
Can we not get that from the difference between the arrival and departure? Because super fast trains, their difference is going to be less, and if it's a passenger train, then 5 to 10 minutes or whatever time.
Depends, but you can't justify that thing. Like they can't generalize that thing.
Yeah, because then in that case, if the train is just not stopping and just crossing,
that's always a super fast train.
yeah.
But they would stop at certain stations, no? Like
Yeah, they would, but like at one platform, if you're talking about, so we just need to know is how much time do the platform need to give to this train for it to just go.
that is depend on the departure and the arrival time. Platform
Yeah.
has no relation to how much time it should give it to a train. Once it's allocated, a train is allocated a platform. I think it's all depend on its departure and arrival time.
Yeah, that's fine. But status to me it looks little.
It's a property of the train. It's just the property of a train. Whether you category what you say. I think till now, if you go and see, I think they would have the category. That's a good super fast train or a passenger train.
Okay.
The reason I get to know it is because when I book it in IRCTC, they always say you have some super fast charges or this kind of charges. That's where I understand that they would have a train would have its own status or a category.
train should also have a method or something like to calculate if it is delayed or not. We can have the current time and the arrival time, something like that. So it shouldn't the method be a part of the train is delayed or something.
Add those methods. That's okay. These are the entities, and of course, you need to add certain supporting methods. I would say we can add those methods. I'll just add. Yeah, we should add it, but with the interest of time, I just want to say that there are methods. What about platform?
The number
Just took the
is it empty or not?
number is always there with the platform. So
is it empty or not?
Okay,
Or
is empty.
Yeah, is available platform number.
Number is empty or available. Anything else you guys?
Direction, does it come in platform? Like what direction the train is arriving at, or
I
it's the
think
train
That's the trains.
that should be
component?
trains entities.
Trains
Trains
component. Yeah.
Then you can
Yeah.
keep on adding more stuff like its origin, destination. A lot of other things are always a part of train, but with this context, we are just limiting stuff. So train and platform. Is there anything that you want to add to a platform from the problems perspective, I would say?
Maybe is it serviceable or not? I mean, is it available
Exactly. Yeah. Is it serviceable or not?
But that is available, isn't it?
No, serviceable if it becomes false, it can be empty true. Still, you cannot allow a platform train to this particular platform. That means this is not in service. So your reduces down to m-1.
Yeah. I actually I was pertaining availability to serviceable, whether that platform is in service or not,
Okay.
and then whether it's empty or not.
Empty. Okay. Cool. I think these three properties would suffice for the platform.
Yeah.
Now, Divyansh, as you said that we have only one service, though since we have a service, one thing that Anushka said is that we have one endpoint, which is the request platform.
Correct.
And of course, the train needs to request a platform. So that would be the object that would come, the train object. What else? What are other endpoints that you expect? And this, I would call this particular thing as a railway management service. So what else? What all endpoints do you expect this service to have?
Notify
Train
back to
should
train.
leave the platform.
Yes. So yeah, I would say depart notification. Again by a train only.
And a platform availability, like once a platform becomes available, then there should be a signal that fires.
Give you a signal, no? Depart with the platform number.
Yeah.
So there should, like depart, there should be /arrive notification also. One is a request that you have got a platform, but then there should be a request for that arrival also. Some data will go.
But then you have to give it to train. How would the management system give that note?
Okay.
That is a notification system. So train, when I said methods, there is one method that is very important in this, and that is like one second. Arrive and then platform number. So maybe this system or this service can call this particular method or the service endpoint. What else in the railway management system? We have discussed about the two endpoints. Do you guys think that there needs to be a third endpoint, or is this fine, or what else? That all the three things, the train entity, the platform entity, and the management service, two endpoints. Do you guys think this would suffice to your problems scope for now? And then we'll come over the internal workings. But
Platform assigned kind of thing, like when a platform is assigned to a train.
platform assigned to a train. So if you're saying if it's not empty, then you should know which train it's being assigned to in the platform there.
Yeah.
And keep that thing.
I'm also not understanding if you are requesting a request platform and if it gives no platform, right? It is not available right now. If there is no platform available in this /request platform, then how will the train know which platform to go to? It will keep on requesting.
That is the logic that you guys have to build right now. We are not come over there yet. And of course, there are multiple ways to solve it. I'm just saying, how would you build it is a question. And if you feel like that, you know what, you need to improvise on this thing, you can always go back and improvise. But let's say that logic needs to be built, how that response would go back. Like when you design an API, you always think of the how would you send back the response and all those things. So yeah, of course, I think somebody said that if it's not empty, then the train number over here that can come. Does that solve this thing?
Yeah.
Okay. So now these, okay.
One more thing, which I could, I mean, it's a very edge case, but I mean, whenever a platform is signed, we are assuming that we need to make sure that we tell the status of the current platform to the train itself. So, I mean, whenever that train requests a platform, we are assuming that the platform is assigned. But let's say at that middle of when this platform is unassigned, how would the train know again that you need to stop or something like that?
That's the job of this particular service, no? The railway management service, to actually take care of no accidents, assignment and unassignment and all those things. They are just entities. They don't have any trains to do anything, like train and platform. Manchus, does that solve the thing for you?
Yep.
Okay, so coming to this thing, the request platform and the depart notification from the train and this thing. How would you solve the two things, the two endpoints? I'm not talking about the most optimal code. I'm talking about the clean code as well as the correctness of the solution. How would you like to solve these two things now? Anyone wants to take a stab at it?
I think for the first one, we could follow an asynchronous kind of request, a reactive, when the train sends a request. Then rather than, because when the train sends a request, then platform may or may not be available, and if it's not available, then it's gonna say, okay, I'm not available. Then we need to decide that now the train is just not going to stand there forever. It needs to send the request again to know whether it's available. So rather than train sending request again and again, it can just send once, and then the platform can be reactive and send a request back to train. Now I'm available, you can come. Some sort of that approach I'm thinking about the first one.
Okay, you are on the right track, but the platform is, as I told it before, the platform doesn't have any brain. This needs to be done by the railway management. No brains with platform or train.
So
I have a
And in
question,
that case,
Keshav,
we
like,
need to. Oh, sorry. Yeah, go ahead.
yeah, sorry. So I have a question, like, how we are managing the trains that are coming? Like, are we
That's
taking
what
them in a queue, or
that's the solution I'm looking for now. How are you managing the trains that are coming and requesting this thing?
I think we need to manage them in a queue that can be a like
Can you
priority based, non-primitive
okay?
kind
Can you
of.
think
Yeah.
of the solution in this particular part, the request part and the depart part, and how would you make it club together? Like you have
Yeah.
what we are looking out over here is a train. I'm as a train. I'm coming to a station and I'm saying I need to request a platform. I should be notified as what somebody, I think Anchal, you said that you
Yeah.
only take the request once, and if it's available, you respond or whatever. If it's not there, you respond once it's available. Whenever the priority or whenever the train's number comes in, you respond. And once the train arrives at the platform, it will send back a depart notification once it departs, and then you have to take care of how would you assign that empty platform to the next available train or whatever. So if there is a
for
next available train.
first
So
of all, we should have a some set of platforms and their status, like which are available or not. so that when a request comes, we can check if a platform is available for us.
Okay, so
Can we have one more endpoint here now? Because as you said, that platform has no brain. So, but the railway management system can have one more endpoint which will send back to the train now that you can come.
yeah, that's what we added. So if you see, I added this arrive method in the with the platform information to the train. Since you already have a train object coming in or train coming in, you can just say train.arrive at that particular platform.
No. What I meant is that there is this request platform. It's coming from the train that I want to come and can I come or not. Now this management service has to notify it back to train whether the platform is available or not. So as we said, that train cannot keep requesting again and again because the train does not know. So if we want something kind of reactive, can we add one more endpoint here, which is the service can send back to the train?
Yeah, we are adding this end. That's not an endpoint to the service. That's an endpoint in the train system. You need to notify the train, not the other way around. So you need to have that endpoint or whatever method I called it, but in the train, not in the service.
So can it be an app or an application which notifies the train, and then the train also notifies the app saying that I've arrived at so and so time, and then based on availability, you get notified saying that you can now come to this platform.
Depends. We just made it simple by adding a endpoint. Now you want to keep it above app or you want to keep it behind a UI or anywhere. That's completely fine.
Can we do it like this, Keshav? Like we have a queue, and whenever a train hit the slash request, then we just mention that train into our queue. Like you need to wait for some time, and whenever slash depart executes, it frees a platform, and we pick up first train in our queue and assign that platform to that queue to that train actually.
If I'm taking it right, you said request comes, put it in queue. Which
Yeah,
kind of queue? You want to keep it a FIFO queue or a priority queue?
the priority queue,
Okay,
because
priority
we
queue.
are giving
Okay.
priority. Yep.
Whenever a depart comes, let's say it takes a train and a platform as an input, pick up the the train from priority queue and assign
Yeah.
platform.
Yeah, kind of this something.
Okay.
Because here is one edge case for the initial scene, like when all the platforms are empty,
Mm,
then how we should assign platforms.
yes. That is just one edge case that you are thinking of.
There might be a lot of.
But in this case, it will mean that train 1 is requesting the platform, but you will give T2, train 2, which is there in the priority queue. You have to tell train 1 the status, no? That what the train 1 has done the request. So in the priority queue, train 1 would not be in the front, no? Like we
That
cannot
depends
on
on your
this,
priority queue order, like how you want to decide a
but
priority.
on this action, we cannot pick up uh from the priority queue and assign the platform when the train is requesting, when a train is making slash request.
I am not getting it actually. But let me come to you just 1 second before I come to you. I just want to close that conversation with Ekant. That you're saying that there is one edge case, but there's another edge case that it may happen that there are two trains that called the depart at the same time because their departure time was same, and that can happen. So, and there would be one train in your queue, and if you pick it up, and you always call pick up the train from priority queue and assign, so you basically would assign a train to two platforms, P1 and P2. That is also
Got it, got it. So I think for this we have to
you
manage
think of a
one.
solution. Let me come back to
Yeah,
you.
sure, sure.
Just think of your solution because that's not right. Okay, Divyansh, yeah, coming to you.
No, now thinking in another direction. First this service needs to have some information about the platforms.
You said
So
set of platforms. I removed it. Okay, slate of platform.
set or a table of platforms where we can directly access which platform is like available.
You do a for loop. At max,
Mhm.
there would be 100, doesn't make a difference.
Yeah, okay. Yeah,
Got
makes
it.
sense.
Then what?
So, yeah, so you have a platform. Hmm. So like if there is a platform available, so whichever platform is available at the first in this for loop, you just give it back in the response to the train.
Okay, so there is a platform available, you will respond. So I'll just take it as a separate approach. You respond if platform available, else what?
Else put it in the priority queue.
Is this right? What I wrote? Respond with if platform available, else put it in priority queue.
Yeah. So if now I'm considering the case when two requests comes in parallel of two trains. Now if the platform is available,
But if a
so
request comes for a train and there is one request in priority queue and there's only one depart has also happened. So that means only one platform would be free and a request is come from there and a request is there being picked up from the priority queue. You would assign one platform to two trains. There would be a race condition with that.
Mhm. Mm.
I think there's an alternate approach we can take. I mean, we can have another endpoint
Yeah.
for a booking status, and every request for a train, whenever it requests for platform, we can send a reservation kind of thing
Mm-hmm.
to the train. Yeah, this is your reservation. Just
Mm-hmm.
check, just poll for the reservation in some time. I mean, you can poll for it multiple times or do a long polling kind of thing. And the train can, even if the reservation is completed before the train is even arrived at that platform, it's possible that that platform is, I mean, not serve. I mean, it's not serviceable at that point, right? You need to cancel that booking, I mean, reservation at that point also.
Yeah,
So
but then do you want to keep it in that manner, or you are actually increasing the load on your system?
yeah, yeah,
So
that's it.
you can easily keep it by a notification system or like an endpoint in the train. So why do you want to increase the load on the system?
Yeah.
Anyone who wants to take a stab at it, or else I'll take a stab at it.
Just one more scenario, Keshav. Like uh, initially we have a problem when a depart executes, then there might be a scene when there is only one train in the queue and we have two platforms available. Then what needs to be done?
There,
So in this
there is, sorry, one train in the queue, and there are two
and
platforms.
two platforms got available.
Mhm.
So can we do it like this, like one set of platforms that Divyansh told that we can manage that, and for the initial case when there is a no train and all the platforms are available, we just enter all those platforms into this set, like all these platforms are available. Whenever our train come, then slash request executes, then it first checks the set. If our set has some platforms available, then it assigns to the train, and if it is not, then the train needs to be in the hold in the queue, in the wait queue, and whenever slash depart executes, it like first checks is there any train in the queue. If there is any train, then it assigns that platform to the train. Otherwise it just enter that platform into the set, so that whenever a new train come, it just directly check into the set.
So again, you're trying to solve it by putting a more hack into it if an else condition, but it can still result in a race condition. Because when you check whether that's in a queue, it may have been removed from the queue, and then you do it at the platform either in the left hand side as well as on the right hand side. So again, there is a you can't solve it. You try to solve it, then you will get up with a race condition. You need to think something else out of it.
Okay.
You keep on adding more if and else, you're just complicating. Like will complicate the stuff. What I would say is let's basically I'll say how I would have approached this thing. You have a request and there was a depart method. As rightly pointed out, we would have put it in a priority queue. As rightly pointed out, we would have made this platform P or this platform available. As rightly pointed out, we have set of platforms that's there. I would have kept a scheduler service or scheduler running in background that checks for the priority queue train. So basically checks for a train in priority queue. If found, checks for empty plus serviceable platform assigns. If you do this way, you are actually doing in a single threaded manner, and this will solve your problem of any race condition. So if I would have approached this problem, I would have generally kept it as a producer to the problem, and the consumer comes from here. So it's a different type of a producer consumer problem, but it relates to that only. Yeah, there are certain problems like there are like I kind of form these problems by myself, like a dining clause. Well, we can talk about a lot of problems that I formed. So yeah, one of them was this. Is it like is it fine with everyone? Does everyone like understand what how we can solve this thing and how?
Can you just repeat this flow again? Like when a slash request is coming, what all is happening after that step by step?
So you just put it in a priority queue, and when a departure is coming, you just make that particular platform available.
Okay.
Okay, so now the thing is, the train is just sending a request. So what are we telling? We have put it in a priority queue, but what are we telling the train?
You don't give anything. You just say, I have taken your request, that's it. Now you have a scheduler. It checks for the train in the priority queue. So whatever order that somebody said that we can have multiple scheduling. It's better you have one scheduler, because then you will not have a problem of these race conditions. But whatever logic you want to put for that priorities of the train, you can put it as in the priority queue concept. Now, once you find a train in the queue, let's say there's a train that exists in the queue, and you check for an empty platform which is serviceable. And once you find that, you have first combination over here and the first combination over there. You call train's endpoint, because you have kept the train object in the priority queue. You call train endpoint and say that arrive at this particular platform.
I did not understand this last thing. How will we implement this train arrive at? How will the scheduler let the train know
You
that
can
Yeah,
it?
that's the link I'm missing. How we are
yeah.
knowing, how we're
So
letting the train know.
so what you think in what you are putting in the priority queue is a train object, and when you extract this train object, and there are multiple ways to do it. I'm just saying how I would have done it. You can say, okay, instead of this, like I'm just saying in a simpler manner what I would have done. Now you know that you have assigned a train, you have a train and you have a platform. So you can say, okay, hit the endpoint of this particular train with this number 2101 something of that sort, and arrive and give a platform number equals to P1, P2 or whatever. So this endpoint is a notification endpoint that goes to the train. That's one other way. Once you have figured out which train needs to be assigned which platform.
But in this case, then the train, something needs to be like, it should be like subscribed to our, how will we send the, so this service scheduler will send this request to this slash endpoint slash train slash 2010. Now, if it sends to this, so how is the, again, the question is
I
how
think
is,
it's more of an asynchronous processing we are talking about,
Yes.
like a webhook or something.
Yes. So I already said that we'll have a method of arrive at this thing in the train.
okay.
This method is very important. That's where you have to think and improvise. But since one thing that you guys missed was you have to, platform can call this thing to status of serviceability. That if you want to change the status of serviceability, that was missing. Does it answer your questions, guys? Like, is it fine, like the solution that we have figured over here? Any questions anyone has? Any concerns? Anything? And there are multiple
So
ways to solve. There are like,
yeah. Sorry. Can I ask a question now?
yeah.
Yeah. So my question is like, how to arrive at this, right? Like when you actually posted the solution here, I knew exactly, okay, this is what I had in my mind, but I just like could not portray it in the way that you have, like probably technology, right? Like in my mind, like I was thinking, I was visualizing a railway station, and then there is a scheduling or the railway management system, and I had people associated with it, where train is saying that I've arrived, and then someone is notified. Uh, Maybe that translation to technology is what I am struggling with. Does that come with experience, or like what is how would you guide a person like to put that into technology?
Yeah, I think rightly asked. It's the experience that plays, and of course, when you come in these sessions, so that's where if you see there are a lot of system design stuff available, like content available on the internet, and they'll talk you about. If I go back to the first part of the thing, they'll call out 1, 2, 3, 4, and if you come back to the solutioning of this particular thing, first thing that you like people saw was an HLD. That was the first thing. The second thing is they came up with certain solutions over here, and every solution had a problem. This, if they come up with this solution, they very well need to they very well need to defend their designs, as that is where practice plus discussions like this always help, because you will think out of the box with these things. Otherwise, there is no other option. Like, unless somebody asks a right set of question, you if you if you think of these solutions by yourself, you'll always say, yeah, I'll put it in a queue and I'll pick it up and all. Like, maybe you may consider one of the race conditions, but when you come and meet as a group, you'll consider n stuff that would be coming along with it. And the more the merrier is, and the more interactions you have, the merrier it is for you. So this is all experience, I would say. I think eventually you guys will build that confidence, so to come up with these solutions. So I think and the reason I tell this is because I have had a lot of courses and been nice to work like in Expedia, and but now I want to keep it at a like a generic level so that people can join from various firms, and that's where you get a lot of exposure, just with not your working, but to a lot of other firms. Like, in the real world now don't get to work on the breadth of problems. You have to work on the depth of a problem. So when there are 20 people who are working their individual depths, your breadth also expands with them. So that's very important, and that will give you a lot of confidence in solving such stuff.
Which would be which tech stack would you have used for this one? Just asking. Correct. Like which, like we have talked about now. So what, like in terms of technology, as what you would have preferred?
Technology
as in like which pattern or what exactly you would have used, like messaging system. Obviously we are talking about the messaging system here, so you use the term producer consumer, so which would you have like?
This is just a queue. You can keep it in memory queue. That's okay. FIFO priority queue. What you are thinking of is, can you hold up for I think 2 to 5 more minutes? I'll come to what you're talking about. So just hold up for 2 to 5 more minutes, and I'll come to that point. But for this particular problem is we are not using anything because the scale is very limited. So we are just said in memory priority queue. You can write it in C++, STL. You can write it in Java. You can write it in Python. Anything that would work. It's just a normal priority queue. Does that anyone else has a question or anything, or I can move to the next part? Okay.
Yeah, Keshav, I have one thing. Regarding like in this current solution, we are not considering when we are assigning priority to the platforms as well, because we are just storing them into a set. So if we want to give them a priority, can we take the priority queue at the platform, and also will this solve this
Exactly.
issue? Or
now, if you want to extend your solution, put the platform available in PQ. So this is a new thing that you added, but your code or solution is extensible. Check for an empty platform in PQ. That's it. We are solving the priority of platforms as well.
How
yeah,
are
got
we
it.
accounting for the delays? If we want to extend, if there is a question now, we want to check, we want to count here for the delays of the train.
Details of what? Like I didn't get it. Like
Delays. If the train is, how will we manage that?
because train when it arrives, it will give you that thing. So any delay, that's okay. When it's arriving to the station, it's gonna give you that request for a platform. Of course, it will have its own departure and the actual arrival time and all those things. And that you can take it in consideration in your priority queue. So whatever you form in the priority queues logic, because there would be a lot of other things like starvation and all those things. We didn't come into play. We didn't even discuss those parts, but there are a lot of other things that would come. But everything can be put up in a logic in priority queue as a comparator. If I talk about Java world or a Kotlin or JVM world. And this can keep on changing. So let's say your business requirement change that, you know what, we need to give priority to a starvation, like a train that is waiting for more than 30 minutes, we'll give it a more priority, that you can do it and change the comparator logic. That's it. It'll be just a rule kind of a stuff.
I have one question. So, in the scheduler class, I mean, whichever way we are scheduling it, will it also be the source of truth for platform status? I mean, the scheduling logic is single thread logic, right? But what if when you assign a platform to a particular train and that platform status is changed, how will you make sure that it's single threaded or not?
This is single threaded, so it's changing that thing. No? Why do you want to I'm not getting it.
I mean, is the scheduler, hold this method is the source of truth for the platforms as well?
You put the platform in a priority queue over here. That's just producing in the priority queue.
Mhm.
So
I mean, yeah,
this
I'm
is
asking if
extracting
the,
from the priority queue.
yeah, I mean, I'm just saying that when you assign a platform to a particular train, and what if when you check for an empty platform, you know it's serviceable, right? But let's say when you assign a platform to a particular train, how do you make sure that that platform is still serviceable?
Okay, so you're saying that you assign and the serviceability goes away from here.
Yeah. Yep.
That you have to take care of again. That's a race condition. So when you implement this particular part, you would have the status of that platform from your angle. Maybe you need to then incorporate it as a part of, like, that's a business requirement. You have assigned a train to a platform, and then it becomes non-serviceable. How that business wants to handle. So maybe if that is the case, you can have a notification that do not arrive and we'll give you another next available platform or something. That depends on your thing, but we didn't go into the depth of that level. We can always work on that part. So that can again be extensible, but your basic crux logic becomes still the solid. It's not like you have to rebuild your logic based on something that get added to this thing.
And not even on the I mean, notification part. I was asking in the code part itself. I mean, we know that this scheduler part is a single thread platform, right? I mean, that single thread, right? This function.
Yeah.
But is this scheduler also the source of truth for platforms? I mean, there should be a different class for platform statuses as well, right? So
This is
maybe a
so you can
different
keep
thread.
a set of platforms in a different class, which is your global object, and refer the platforms from there. It can also maintain the priority queue of that platform. And if you want to remove the platform or priority queue from that thing, that's okay. If you change the status of the platforms from there to make it non-serviceable, that would be reflected over here, because that's how you implement the code. Like, you have a global object and it just pull references out from the like this scheduler will reference from there. So that's a more of an implementation perspective. How do you want to do that?
One more thing. So basically, like, even if we see this, so basically one thread is your scheduler, and then their APIs are running on basically another thread, and your like the resources like priority queues and are being shared between both of these, right? So basically accessing these shared resources should happen in a synchronized way, like a synchronized block or something.
I'm sorry, synchronized block, why do you need it?
So basically, let's say if we are removing departure time, and it's adding a empty platform to the priority queue, right? When a train departs, and that is a separate thread, right? And then this scheduler thread
But
will also have the exact.
see, the problem of synchronization would occur if two threads are consuming or two threads are producing. Right now, there are two threads that are producing to two different priority queues and one thread that is consuming.
Yeah.
There will be no synchronization issue.
Okay.
Okay. Now the next part of the problem that comes up is, how do you scale this particular system that you have formed with respect to Indian railway system? Now there are multiple railway platforms, and how would you multiple railway stations and n number of platforms, and everything increases, and like, you know what is the scale of India. So how would you now build your system to incorporate this particular part? We don't have to worry about it. I just wanted to give you a flavor of how a simple problem can be extended to a very complex problem by just changing the scale from a simple railway station to the Indian railway system kind of a thing, or India's railway system. Everything changes. And how would you now measure or form this particular thing through, like, at the scale of this thing? So you have a centralized railway management service now, or system or platform, to do this train allocation, but at a scale of Indian railway system. So probably next time we would try to, or we would go over with this thing, and we will try to figure out how we can scale this particular solution or this particular problem with this particular scale. Yeah, so I think this was what I had in my mind. Anyone has any questions, concerns, any feedback before we can wrap it up, and then we'll see you in the next webinar series whenever that's fine there. So yeah.
So would it be a follow-up of this, the next webinar?
Yeah, that would be a follow-up.
Okay.
And we'll take this problem. And the reason I gave it to everyone is that you guys can go and think about this thing, so that when we meet next, it's gonna be easy for you guys to actually come up with a solution. You'll have plenty or plethora of time to come up with a solution. Let's see.
Just a point, Keshav, like where we get the notification about the next webinar on your LinkedIn,
Yeah,
because it might miss if I like not open LinkedIn for 1 or 2 days. Can we receive an email with the top mate?
There is, I'll send a feedback mail. One top mate will send today, but that's okay. But I'll send one feedback mail tomorrow or on Monday. It will have a community link for us webinar stuff on WhatsApp. Kindly join that. From there, whenever we have the next session, I'll post there as well, so that you guys are well informed and you can reserve your spot. So generally I take 20-25 folks, that's it, not more than that is what I do. And
that's good, thank you.
Yeah, I generally try to keep it as interactive as possible so that people learn, and that's where it is. But yeah, adding more people always helps, because that's where it adds the more benefit of trying to protect your design. Again, people will question. Like I was really impressed. Somebody said that why is it a multiple of n when we were discussing the throughput, and then Divyansh had to come back and say because there's a practical number to it, and that's where he would have learned how to defend his numbers, what he is coming up with, because people will ask you question, be it in the interview world or the real world. Interview is just one person, but in the real world there would be n people who would be judging you by your design skills and all, and that's how you grow in the career. So I would really appreciate a feedback on LinkedIn as well, so that people learn from this, and also on anything that you guys would want me to improve. More than happy to take the feedback. Okay.
Thanks, Keshav. It was a very informative one. Thank you so much.
Thanks, everyone. Thank